Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are continuing with our Chapter 3 review on the worksheet. This is the Big Ideas book. We are looking at quadratics and how to graph them, complex numbers. In this case, we are starting with nonlinear systems. We're going to continue with graphing inequalities, whether it's a system of inequalities or just an inequality on its own that needs to be factored. And then graphed on a number line. So we're going to start off with this, and it says to solve the system by graphing. So we know we're going to have to graph something. And that was not a line that would be nice for graphing. So here I've got my y-axis that, okay, oh, that's weird. Okay, here we go. And we have our x-axis. So we're going to label it x and y, and we're going to get started with the easier one, the linear one. So I know in order for this to be a line, we're going to go ahead, we're going to get y on its own. So I know in order for y to be on its own, I can kind of like flip-flop these two, where I add the lines 3. So I'm going to end with y equals 2x minus 3. And if I where -3 is, let's say -3 is somewhere here, that's going to be my intercept. And then I'm going to go to 1, so I'm going to hit kind of 1 section, then I'm going to go up again, and then here, so on and so forth. I'm going to go ahead and just pick these dots with a really long line and just put it over so that we can see kind of in the general direction. Okay, beautiful. So that's the easy one we've got down. Now let's take a look at the quadratic. Very first thing that we're going to do is we're going to find our symmetry. The way that we do that is we do -b over 2a. You'll find a lot of b over 2a, b over 2 kind of every single time we see quadratics. Now, I haven't learned all of the history of that, and you can't explain why this works, but it will always work. -b over 2a is your relative. So if my is are negative, we're going to put, and then 2 times a is 2, so 4, and that's going to be 2. So my axis of symmetry is going to be right down through here. Mix this. Not straight. Okay, so that's my axis of symmetry. That's kind of where I'm going to put my vertex. So then I'm going to go ahead and I'm going to replace each of my x's in here with the number 2. Okay? So I'm going to do 2 and then times 2 squared minus 8 times 2 plus. So 2 squared, remember order of operations, we're going to do exponents first before we multiply. So 2 to the second power is 4. 4 times 2 is 8 minus 16 plus. So one of the things that you're going to notice every single time you're going to look for your vertex is you're going to find that the first term is always half of the second. But if you're afraid and you're just not sure what the answer is going to be based on the solution, it's always going to be this number. And depending on whether or not this is a positive and negative, whether number is bigger, it'll either be negative or positive, right? So 8 minus 16, negative. Plus 5 gives me negative. So my vertex for this particular quadratic function is going to be 2 negative x minus 5,000. Now, next thing that I know is I can do a couple of things. And I make an exportation where the center point is going to be value 2, then I'm going to have 1, 0, and I'm going to have 3 and 4. So I can figure out where my graph is going to be placed. I can also turn this into a vertex form and then see that my A is like 1 or 2, and then based on that determine where I'm going to go with my graph, whether I'm going to move up, up 2, up 3, up 10, up whatever, and over 1. Or you can do this table and say, okay, well, 2 is going to be -3 because I know that from here. But then what is 1 going to be? So now I'm going to go in, I'm going to replace each of these x's with the number 1. So 2 times 1 squared minus 8 times 1 plus 5. So we know 1 squared is just 1 times 2 is 2. 2 minus 8 is 5. So again, now that we're not doing the vertex, this math is not going to be that kind of like one number is half the other. So I'm going to end up with -6 plus 5, so -1. And so here I'm going to have -1. So now I'm going to go 1, -1. Oh, take a look here. This is one of my solutions, right? This is where one graph meets the other. I also know that I'm going to have 3, -1 as another option because I know that my axis of symmetry is a line of symmetry, and I'm going to have the same thing on both sides of the equation, or both sides of the line of symmetry. And then I also know when I plop in 0 in here and here, this information will kind of be 0. This information will also be 0 because 0 times anything is 0. And then I'm going to end up with 5 on either side. So then I'm going to go in, I'm going to say, okay, let's say 5 is somewhere here. I'm going to have a point here and a point right here. And so if I were to graph, okay, this is a terrible line. Okay, well, that is not quite what needs to happen, but you guys get the idea. We're kind of going in this direction. Okay. Granted, you will have better looking graphs because you'll have the lines, the x value lines and the y value lines going through, so you'll be able to see a little bit better. And then you'll be able to say, hey, these are my solutions. I anticipate that if I put 3 or 4 into my x value, I might end up with a 5. But that's kind of where we're headed. You want to make sure that you can graph the text all the way through. But the next problem is very similar. Again, if you want to go ahead and attempt it on your own, then come back and check the answer. That's totally fine. Know that your graph will be better than mine, and I'm totally fine with that. So we have in here an x and a y axis. And we know that we're going to have to do a couple of things for this one. So in here, we're going to go ahead and find the axis of symmetry, right? And so in order to find my axis of symmetry, I need to do -b over 2a. So if it's 6 is already negative, so I'm going to have 6 over 2 times 3, which is 6 over 6, which is 1. So I'm going to find 1 here. And then that's going to be where my axis of symmetry is. We're going to move it slightly over. So here's my axis of symmetry. I'm then going to go in and find my vertex. So I'm going to have 3 times 1 squared minus 6 times 1 plus 5. So 1 squared is 1 times 3 is 3 minus 6. Again, we have this 3 minus 6. So that's going to be -3 plus 5, so 2. So now I'm going to find 0.2, and here is my vertex. I then go in and I get a table of values, right? So I know my vertex is going to be in the center at 1, 2. 2 numbers below 1 are 0 and -1, and 2 numbers above are 2 and 3. We always want to have 2 numbers like either below and above or both so that we can figure out where the next points are going to be. So I'm going to do 3 times 0 squared minus 6 times 0 plus 5. Again, this is going to be nothing, and then I'm going to end up with a 5 on either side. So I'm going to go ahead and I'm going to find 5. Let's call 5 somewhere here. So this is going to be part of my graph. Then I'm going to do 3 times -1 squared minus 6 times -1 plus 5. So this is a +6, +5, and that is a +3. So 3 plus 6 is 9, 9 plus 5 is 14. And that's way off of my graph, so I'm just not gonna graph it in here, but on your end, oh my goodness gracious, that is a terrible, terrible line. So my graph looks kind of sort of like this. This is where I'm at. Again, your graph will look better because you actually have that piece where you are capable of graphing because you have the lines, right? This is not conducive to anything, right? Okay, and then we're gonna go ahead and we're gonna do this, right? So now this is already in vertex form for us, so we don't have to do all of this math to figure out vertex form. And because we know that our A is 1, we know that it's going to be kind of like a rise over run. Our slope is going to be just pretty basic throughout. So my vertex in this case is going to be 1, positive 2, which, oh my goodness, look at that. That's right here. And then we know we're going to go up 1 over 1. So I'm going to hit this at 3. Because all of my parabolas are going to look like very similar, right? They're always going to have that slope of up 1 over 1, up 3 over 1, up 5 over 1. They're always going up by an odd amount of numbers and then over by 1. So the next one will be, instead of 3, it'll be 6, negative 1, and then, oh, sorry, not 6, negative 1, negative 1, 6, and 1, 2, 3. 3, 6. And so that graph will kind of look like this. So when they're asking for these are terrible graphs. When they're asking for a solution, the solution is where the two graphs meet. In this case, the solution is 1, 2. So in here, the solution would be this point right here, this 1, 1, negative 1, as well as wherever it meets up here. So there will be one more solution. I just can't talk about my graph that it is. Okay, now we're talking about inequalities, looking at what those things are. So if we take a look, we're still going to graph, right? So we still need x and y. And let's take a look here. X, y. We're going to label the x and y, and we are going to get started right away with this particular graph, because this one is an interior. It's already in vertex form, so I know that my vertex is going to be 2, 4. I'm going to say here 1, 2, and here's 1, 2, 3, 4, let's say. And I know from this point, my A is 1. So I'm going to have the same kind of slope as I did with the last one. I'm going to go up 1 over 1, up 3 over 1. Then here I'm going to go 1 over 1, and then 3 over 1. And this is going to be my parabola. All I need to know how to graph in this particular case. Now, here's another thing. We know that this is a less, which means I know that everything less than this group is going to be shaded. Before I go into that, you know that usually some teachers require some sort of work to show, is this really where the graph needs to be shaded? It really needs to be shaded below, it's really needs to be shaded above. So if that's for work, you're actually going to replace x and y with this point rows. So the point is not in your graph, it's not part of your graph at all. It is a good point to check, because here's what'll happen. You have 0 plus 0 minus 2 squared plus 4. Or minus 2 is 2, negative 2 squared is 4, 4 plus 4. So I have 0 is less than 8. If that is a true statement, 0 is indeed less than 8. It's a true statement. I know that I'm going to go back for the. So let's make this really large. That's where I'm going to graph this. Also going to graph it here. So my entire graph will consist of lots of shading below there. Now, normally when you're shading on a graph, the text, it just shows up just like lines. You don't have to do anything fancy. If you have a highlighter, definitely by all means go in and use your highlighter and shoot it down, but not an absolute necessity by any stretch of the imagination. So now let's go ahead and let's look at this. The width is how we absolutely want to go ahead and find this axis of symmetry. So again, the axis of symmetry is negative, over 2a. So it's going to be negative 4 over 2 times negative 1, which is 4 over 2, which is just 2. So I'm going to find 2. Oh my goodness, look at that. That's kind of where my vertex is for the other graph. Okay, then I'm going to go ahead and I'm going to find my vertex for this first graph. So I'm going to do negative and then 2 squared plus 4 times 2 plus 2. So this will be 8 plus 2, and this will be negative 4. So I have negative 4 plus 10, which is 6. So I'm going to go ahead, I'm going to find 6. So I have 1, 2, 3, 4, 5, 6 is somewhere here, let's say. So here we are. This is my vertex for this particular function. I do know that because it's just a negative 1, it's going to be a sad face. And I'm going to say that I'm going to go down 1 over 1 and then down 1, 2, 3 over 1 as well. So the, oh, whoops. Yikes, yikes, yikes. Okay, here we go. So I have this guy here, and this is kind of like where my graph belongs. Oh my gosh, these are like disgusting graphs. Okay, that's fine, that's fine. All right, so here we are. We want to make sure that we know where to shade things in, right? So again, I really like this method. If I plug in 0 into here, will my statement be true? So let's take a look. Plus 4 times 0 plus 2. The beauty about 0 is that this is going to be 0, this is going to be 0. I have now 0 is greater than or equal to 2. That is a false statement. So because it's a false statement, I will not be shading down here. I will be shading outside of that. So let's take a look at what that's going to look like. I'm going to shade up top here, over to the side, and over to the side. One thing that I do want you to pay attention to is that this whole section here is actually not shaded at all. There is no shading in there. I mean, well, now there isn't, but there was a moment ago. So your graph will look like this. I know there's a lot of shading going on. I know there's a lot of highlighting. It might be better to have 2 different colors so that you could see where certain things are double shaded, like the double shading happens on the outside of the 2 graphs. There's only one side of shading happening here, one side of shading happening there. So that's just something to keep in mind and think about as you're working on these problems. Okay. Again, we're graphing. Let's go ahead. Let's try to graph again. Excuse me. Okay. And then we have some axes. Let's go ahead. Let's start graphing this very first. So this one, we know that x squared graph is a regular square, regular quadratic one. So the more basics. So I'm going to start with that first. And then I know that it's my 2. So I'm going to go 2 units. So I'm going to get 1 to 2. So negative 2 down here, and I'm going to go up 1 over 1, up 1 over 1 other way, and we'll have 1, 2, 3 over 1, and then 1, 2, 3 over 1. And it could technically go up 5 over 1, but on your graph, I think it might be better. Oh my goodness, these graphs are really terrible. I think it might be better for you to go ahead and do that. So it might be a thing for you to work on. Again, for graphs where you're using actual tools. So that's want to shade it in. We know that 0.00 is not my graph. It's not anywhere that I'm going to end up doing something wonky with. So I'm going to replace y with 0. So I have 0 is greater than 0 squared minus 2. That goes away. 0 is greater than negative 2. So we're gonna go ahead and we're just gonna have this. Okay, it's kind of like this. Perfect. So now let's go in with this graph instead. Again, same business. I'm looking for my axis of symmetry with this negative b over 2i. I'm going to go in since -2, since b is arc negative, I'm going to make it positive. So 2 over 2 times -1. So that gives me, actually, that goes -1 is my axis of symmetry. So go ahead and find -1, and here that is true. Okay. And I'm going to go ahead and replace all my x's with -1. So I have -1 squared minus 2 times -1 is 4. So it's 2 is 4 minus 1 minus 6 is 5. So I'm going to go ahead and define 5. This is like 2. So maybe 5 would be like, let's see here. This is 5. And we do know that this is a typical graph, meaning it's just a negative graph. So it'll just go down 1 over 1, down 3 over 1. So it will look like this. I do want to make sure that you're aware that if for some reason this point shows up on this graph, we might need to change the graph altogether. So I know, for example, that this point right here is one of the points that's within my graph. So this point happens to be -1, 0. So I'm going to replace this entire x and y business with -1, 0. So if my point is -1, 0, this is my y, this is my x. And again, the reason why I'm doing that is because I want to make sure that 0, 0 is an actual point on my function. In case it's not, I can use any other point, okay? So I'm gonna have 0 is less than or equal to -1 squared minus 2 times -1 plus 4. So this will be -1 plus 2 plus 4. Didn't we just do that? Okay, 0 is less than or equal to 5. Facts, true statement. So we know we're going to shade down in here. So let's go ahead and shade in that section. And this is going to be where I'm shading down here, kind of. I eventually it'll go, I'm sure, down kind of out like that. But for the most part, we're just going to leave it this way. So another thing that I want you to pay attention to is just so that you see it's just this section that's double shaded here. It's got the red and the blue. The bottom down here has just the blue. The top up here has just the red. So when you're looking at this kind of function and you're asked for what the solution set is, the solution set is within this section here. Like this is my whole double shaded area. That's my section. That's the piece that you really want to make sure that you have shaded in. Okay, let's go on to the next problem. So the next 3 problems, the instructions say to solve each inequality and graph the solution set on the given number line. So they do give you a number line, but honestly, it's literally just a number line. Like it's not even, there's no numbers on it at all. So we're going to go ahead and we're going to start off by this. So the first thing I'm going to do is because x squared is, there's only one x squared, there's no x involved. We're going to go ahead and we're going to add 64 to both sides. So now I'm going to have 64, x squared is greater than or equal to 64. And we're going to square root this. I'm going to have square root is greater than or equal to both positive and negative. So then we have a number line, whatever kind of number line is. We know that we are going to have positive and negative 8 here. So I'm going to put in -8. That's positive 8 on the right. We know that anytime we have or equal to, we're going to have a closed circle. And then we're really going to need to focus on what can we possibly do in order to create a correct for like a correct solution. So for a better term in the brain. So what we are going to do, we are actually going to test a number from this section here, a number from this section here, and a number from this section here. If my sections are true, then we're going to have a line in that area and a arrow in that area. If sections are not true, then there will not be a line over here in that area. So for example, we know that 0 is a possible option. Is 0 greater than or equal to 8? Not true. It is a not true statement, right? So if I do 0 in my original statement, like 0 squared minus 64 is greater than or equal to 0. This statement is false, and so I will not be granting anything in here because negative 64 is not correct. But then if I like try negative 10 or positive 10, I'm going to end up with negative 10 squared minus 64. Is that greater than or equal to 0? So I'm going to end up with 100 minus 64. And that for sure is a true statement, regardless of what the number is. I know that it's greater than 0. So I know that my arrows are going to point in that direction. Oh gosh, that does not look beautiful, but that's okay. And the same thing is going to happen when I do positive 10. My arrow is going to go in the same direction. Sometimes I do arrows like this, sometimes I do them a little differently, but regardless of how you do that math or how you draw them, you want to make sure that they're super visible for your teacher to be like, oh yes, obviously they're pointing it in that direction. Okay, so let's go ahead, let's take a look at this one. So I'm going to go ahead and I'm going to put it into factor form. So x squared minus 10x plus 21 is less than 0. And then I'm going to factor these guys out. And I'm going to make x times x is x squared. 21, my factors of 21 are 1 and 21 and 3 and 7. I know that if I have 3 and 7, I'm going to add up to that 10. They're both negative. And so x should equal positive 3 negatives and regular 7. Sorry about that. So we're going to go ahead, we're going to create a number line. Here is my 3, here is my 7. I know that since I have this sort of inequality symbol, those are going to be both open circles. They don't have to be that big, but whatever floats your boat. Honestly, it's fine. And now we're going to go ahead and we're going to try something different, right? So we're going to try a 0, we can try a 10, and we can try maybe 5. Okay, the numbers that I'm choosing to try are numbers that I anticipate will be easier to work with, right? When I do 10 times 10, that's going to be 100. That's going to make my life way easier. Okay, when I do 0 times 0, that's also going to be, or 0 times anything, that's also going to make my life easier. Okay, you can choose 1 over 27. That's an option too, but that's going to make your life harder. And who needs that in their life, right? Nobody. Okay, so my very first thing is going to be 0 squared minus 10 times 0 is less than negative 21. While 0 minus 0 is 0, 0 is not less than negative 21. So this is in fact false. I will not be putting anybody here. That is being not the thing I'm going to do. So let's go ahead, let's try the other side. So I do 10 squared minus 10 times 10. Is that less than negative 21? That's going to be 100 minus 100. Okay, so that's going to be again 0. So that's not a thing. I know it's going to have to be in here. Now, a couple of options. Option 1 is I have proved that both of these sections are false. So I know it must be within this, right? So that would be my solution set. It's kind of like where we're going to go in and that. If your teacher wants additional proof, additional information, you're just going to go ahead and plot one of these numbers, 4, 5, 6, into your x here, solve, you'll see, okay, totally works. Now on this last, we're going to do the same exact thing. We're going to have 3x squared minus 5x plus 2 is less than or equal to 0. In this particular case, you can do a couple of things. You can actually go in and factor this if you want. Or you can go ahead and use quadratic formula. I know that I can factor this into it's a little easier. You're going to go ahead and do that, but definitely feel free to do quadratic formula. So I know that negative 2 times x is negative 2x, negative 3 times negative 1 is negative 3x, and together when I add them, it's going to be negative 5x. Beautiful, ta-da! I've successfully completed this chapter. Then I'm going to go ahead and set each of them to 0. So 3x minus 2 equals 0, x minus 1 equals 0, x is going to be positive 1. Here, x is going to be positive 2. So when I do have my number line, whoa, that was weird. When I do have my number line, since this is exactly what the number line looks like on the paper, I can just go in and make 2 points. I know that 2/3 is smaller than 1, so I'm going to put 2/3 in here, and I'm going to put 1 in here. I also know that 0 is somewhere over here. I also know that 2 is somewhere over here. Now, this is where it gets a little tricky. I can put something in here like 5/6. The reason why I know 5/6 can go here is because I know that 2/3 is the same thing as 4/6. Something that's larger than 4/6, but not quite 6/6, 5/6. And then I'm going to go ahead and I'm going to try those numbers in my function. Now, here's the interesting thing. If I put 0 in here, that's going to create a 0. That's also going to create a 0. Is 2 less than or equal to 0? False. So since 2 is not less than or equal to 0, I anticipate I will not be graphing anything here. I can also attempt to put 2 in here. So I can do 3 times 2 squared plus 2 is less than 5 times 2. So here I'm going to have 2 times 2 is 4, times 3 is 12. 12 plus 2, 14 is less than or equal to 10. Also false. So again, I anticipate I will not be graphing anything here. However, that does mean that I'm going to have to graph something in the center. Oh, we did not even make circles, guys. What is happening here? Okay. So I have these less than or equal to, so I know they're going to be closed circles. So you want to just make sure that you're fully functioning here. I don't recommend having these like squiggles on the sides because I feel like that might interrupt your teacher's thought process. Maybe even the same thing for here, not have these like little, oh goodness gracious. Oh my goodness, what the heck is happening? So we're gonna go like this, just so that it's a cleaner graph. It's a graph that makes your teacher's life a little easier, right? The easier we can make their lives, the better our lives will be. All right, so this is the 3rd video out of 4. Definitely keep a lookout for the 4th video, and I will see you then. Bye.